Okay, so now we are going to talk about the various kind of instruments. Those are used to measure for measuring purposes in physics. Like the first one we're going to talk is about the Vernier scale. Now we know how the normal scale looks like. The normal scale that we use are in centimeter, and each one is, suppose this is 1 centimeter, this is 2, 3, 4, 5, 6, 7, 8. This is how it goes on, right? So suppose this is 0, this is 1, this is 2 in centimeter. Okay, I'm sorry. This is this whole thing is, this portion is 1 centimeter. This portion is another 1 centimeter, but in total 1 and 1. This is 2, and from 2 here is 3 centimeter. And the small units which are there, saying that 1 centimeter is equal to 10 units. You count each unit, there are 10 units, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1 centimeter is equal to 10 decimeter actually. 1 centimeter is equal to 10 decimeter. So this is how the normal scale that we use looks like. But Vernier scale, it's different, and its calculation is also different in Vernier scale. Vernier scale is very small actually. It's very small. It's only of 9 units within it, and Vernier scale is normally used to measure the small instrument in physics and laboratory purposes. When you'll be doing the laboratory stuff, you will see this thing in real life, so you will understand this thing better. So let me just talk about this Vernier scale a bit. The Vernier scale is marked with divisions slightly smaller than the divisions of the main scale. So these are the divisions in the main scale, right? And the divisions in Vernier scale are much smaller than this. This is smaller, but that is smaller than this. So in Vernier scale, this is calculated for measuring very small size of instruments. So, for example, a Vernier scale could have 11 marking. As we know, from 0 to 1 in normal scale there is 10 marking, right? But in Vernier scale that could be 11 marking for every 10 on the main scale. Suppose what it really means is, from here 0 to 1 there are 10 units, right? But in Vernier scale there will be, for the same length there will be 11 units. 1, 2, 3. Okay, let me erase this thing. Suppose this is a Vernier scale. Okay, this portion is a Vernier scale. Vernier scale is big, but for this amount of portion there will be 11 units. So in the main scale, within this portion there are 10 units, but in Vernier scale there are 11 units. In the main scale there are 10 units. So there is a difference, right? And with this difference we calculate measure the devices using this Vernier scale. The 10 division of the Vernier scale for every 9 on the main scale. When there's 9 units, and in the main scale for that 9 units there will be 10 units on the Vernier scale. Okay, things might sound confusing. When you see this in your laboratory, you will understand it properly. But for now, just understand the concept. This means that the Vernier divisions are each of 90% of the main scale division. In this case, the 0 line and the 10th line on the Vernier would pair up with marks on the main scale. but none of the other divisions on the vernier scale would match a line of the main scale. What does it mean? It means that the 10 from 0 to 10 line of the vernier scale could pair up with the marks. That means when you follow the vernier scale on the main scale, this could each and every unit would fall on each other, so there would be no error, right? And they would actually pair up with the marks on the main scale, but none of the other divisions on the vernier scale would match with the line of the main scale. Okay, this is something you actually have to see in your practical laboratory class, otherwise it's not possible to explain if you do not see it visually. Just understand this, for 10 units in the main scale, there will be 11 units on the vernier scale, and 10 units on the vernier scale would pair up with the 9 units of the 10 division of the vernier scale, for the 9 on the main scale. Okay. So these are the concepts basically of vernier scale, and I believe you will understand these things more precisely in laboratory. A few other things are there, which is stopwatch. This is being used for measuring the time, and I'm sure that you have seen this in my map. This is also in the mobile application, so you can know that users of stopwatch. Then there is one thing called balance, which is basically digital weight measuring machine. That what is the weight of a substance that is being measured by a device for balance. Okay. Then I'll show you a problem related to vernier scale. Let's just see that thing. Okay, before that, this is how the vernier scale actually looks like. This portion is the vernier scale. This portion is the vernier scale. The bigger scale is the main scale that we use normally. And within this scale, within this portion, whichever device you want to measure length, this being kept between this. And based on the reading of the vernier scale and the main scale, we measure the length of the specific device or the specific instrument. So, how to read the linear vernier scale? So first of all, read the main scale, that from this portion to this portion of the vernier scale, what is the reading in the main scale. So look for the last whole increment visible before the 0 mark. So before the 0 mark, before it hits 0, look at the increment that has been happened. Read the secondary scale. Secondary scale means vernier scale. This is the secondary or vernier scale. This is the division tape mark that lines up the best with the mark on the main scale. And two measurement together, and add the two measurement together. So basically, one has to do that. You have to read the main scale and also you have to read the vernier scale, and then you have to add them together, and the two measurement together. So let's see a problem related to this vernier scale. I think you will have more clear concept on it.